My name's Ted Lee. I'm an armourer, and I've worked for 3 Olympics, numbers of zonal championships, world championships, junior worlds, and numerous other competitions down to the local level. Having armoured for 26 years, I've developed somewhat of a bag of tricks, which we're going to show you today, starting with the very basic materials that you need to fix foils and epees. What we have here on the table is an assortment of tools, but not all of them are necessary for the very basic matters of taking care of your equipment or wiring blades. What we have here is a digital multimeter, probably the most sophisticated device for testing equipment. This will allow you to fine-tune all of the equipment and the electronics in it. But most people use something more akin to a light box that just gives a very gross indication of whether something works or it doesn't. And here are 2 versions, one which is homemade and one which is commercially available. These will give you nice indications that something is really, really wrong with an epee or a foil. Below that, what we have are body cords, essentially. I've taken an epee cord and made an adapter which hooks into it that allows me to test the 2 most common kinds of foil plugs. One, you have a 2-prong, and the second here is the Leon Paul bayonet. Now, you can make up all sorts of adapters for all sorts of different sockets, but if you can standardize your own weapons, it's going to make it much easier for you and you will have to carry fewer tools. If we go from the body cords down to some pommel tightening instruments, we have a screwdriver, which is commonly found on many of the pistol grips that you have. And next to it is a socket which is designed to fit onto the pommel nuts that are commonly known as the outside hex. Next to it, we have the standard 6mm Allen wrench, and there are probably more of those pommels around than any other. And then we also have over here a T-handled version of the 6mm, which some people like because it allows them a greater leverage to it. The other 3 tools that we have down here are really for the points. We have a screwdriver, which has a blade of 1.8 millimeters, which is just the right size for epee screws and also for the foil screws. We have a small set of ignition pliers, which allow you to tighten barrels, and probably the most useful tool for doing a lot of things, a Swiss Army knife. Now we're going to turn our attention to some of the things that we need for rewiring. Standing in front of me here is a small table vise that is easily removable from a table, and that's going to be an essential tool for rewiring blades. Here we have 2 wrenches which are specialized. They're the right size, 5 millimeters for the foil point and 6 millimeters for the epee point barrel. And next to them, what we have are some point setters, one for foil and one for epee. Here what we have are 2 gauges for setting epee travel. We have a commercially available one, and there's also something that I like to use, and that's a set of metric gap spark plug gappers that are available from most automotive supply places. This allows you to set the tips accurately, and they will last a long time that way. We have here something to keep the blade bent while the glue is drying, and it's nothing more than a piece of chain with some plumbing caps attached to it. Below that, we've got some sandpaper, which is used to clean the insulation off of the wires prior to mounting the blade. And next to it, my glue of preference, which is a cyanoacrylate. It's quick, it's fast, and it holds very, very well. It's also something that makes wiring the blades quite clean. And next to it, we have 2 tools which I use to bend tangs. If you have a heavy bench vise, these tools are unnecessary, but because I travel a lot, I've had to find a way to take some tools with me to bend tangs. And finally, what we have are some specialized tools for very particular tasks. If you're not traveling with a vise, This particular small adjustable wrench is very helpful because it can help you to secure the blade as you're tightening the barrel. And in mounting the blade onto a guard, especially in foil, bent needle nose pliers are very, very helpful. They hold the bottom of the connection while you're tightening it with a screwdriver. And then we have two things which are very helpful for making sure that handles fit onto the blades. One is a file, a flat file, which I use to just shave off a little bit of the tang if it's too large to fit into the handle. And we have a round rat tail file here for creating a groove which relieves the pressure on the wire as it comes through the guard and goes up to the socket. And now that we've seen what some of the basic tools are, let's go and wire a foil blade, see how all of these are used. Here's a foil blade that comes from a distributor. It's been cleaned, the groove is basically cleaned, and anytime you want to wire a blade, that groove should be as clean as possible. There are numbers of ways of cleaning it. Some people use a dip tank with acetone or some other chemical which dissolves the glue holding the previous wire in, or other people will scrape it out mechanically using something like a broken hacksaw blade or possibly a Dremel tool with cutoff discs. But this is a brand new blade, and I'm going to talk a little bit about it and then show you how to wire the blade. Up here we've got a very small thread. Sometimes in manufacturing, up here at the tip, you'll find that it's very sharp, and that can cut the insulation on the wire. So what you want to do is to just make sure that it's not too sharp, and if it is, what you can do is just take the file and make a couple of passes just to take all of the sharpness out of it. Now, what we're going to do is direct our attention to the tang, the part that actually is behind the guard and holds the handle on. Most people want some kind of a little bend in there which makes the foil sit in their hand much more easily. And here's where I use my little traveling bending jig. And what we're going to do is to use these specialized tools, a piece of steel pipe, and we're going to bend the tang. Normally, if you have a right-hander, you're going to bend the tang down and to the left a little bit. And this sometimes takes quite a bit of force. And if you're going to bend it to the left, and there you have a bend, somewhat slight, but it's sufficient for most foilists. When you buy a point or a wire, you need to make sure that they're of the same manufacturer, because sometimes even within a manufacturer's run, you get variances. Here we've got a point, and you can buy either a complete point, or you can buy the various pieces that compose the point. You've got the barrel, which is affixed to the blade. You've got a pressure spring inside. You've got the tip itself, and you've got the two screws which affix the tip into the barrel. And now that we have our tip taken apart, let's put together the foil itself. We're going to use the vise, and we're going to put the blade in it, and then we're going to start taking the wire apart. Wires typically come bundled something like this, and they have to be straightened, as all kinks are going to create possible places where the wire is going to break. So carefully undo one end, and then see how the wire is wrapped together. You don't want to create kinks in it. You want to keep it as straight as possible. So what we're going to do here is just do it in a fashion, unwrapping it slowly. And then what we're going to do is to put it through the barrel. What we're going to do is to take the wire and put it through the barrel. Now, sometimes there's a small constriction there, so you just have to feel your way through. What I like to do is to take and only put about an inch through. This way, if you happen to get the wire caught, you only lose an inch. You don't lose the entire wire. So then we put it into the groove and hand tighten the barrel on there, making sure that the wire runs freely through it. There should be no friction and no dragging there. Then what we're going to do is to tighten it using the 5mm wrench or possibly an adjustable wrench. You don't want to over tighten it, as the barrel can split, and that's just a matter of feel. Normally when the blade starts to torque, that's about tight enough. And then what you want to do is just pull the wire gently through, hopefully not stripping off any of the insulation. And just as you get to the end where you have the contact, be careful to set the contact in there, and then with a point setter, push it all the way in. You should, with a little tap, feel that it's all the way in. Meanwhile, you've been keeping a little bit of tension on the wire so it doesn't kink inside of the barrel. As we keep the wire somewhat stretched, not a lot of tension, what we're going to do is to wrap it around the tang and keep it in the groove, keep the wire in the groove, and just wrap it around the tang to hold it there. There's not a great deal of tension on here. The frame will bring the wire back down into the groove. Some people like to use some tape and protect the wire just by putting a tab of tape here. I'm using electrical tape, which is tape that doesn't dry out. And if indeed they're going to put the blade in storage, they'll wrap some more tape around here. But anyway, with the wire in the groove, you can run your fingernail in there just to see that it's going to seat properly. Next thing we're going to do is to actually bend the blade using our little jig here. This particular jig is adjustable, and put one end on the top, and hopefully without any further mistakes, we can get the bottom on. This will bring the wire down to the bottom of the groove and make it ready for gluing. As we're going to use a crazy glue or a cyanoacrylate, we have to be very careful to make sure that everything is where we want it before we apply the glue, because very quickly after that it's going to set. This particular cyanoacrylate sets within 10 seconds. And to make things even easier, I'm going to show you a little trick that's going to make the glue dry even faster. As we're going to be using a cyanoacrylate, this is a very thin version and it runs, so we have to be very careful. It sets within 10 seconds, so you have to make sure that what's in place is what you want glued where. When you glue using a thin cyanoacrylate, since it wicks, don't start right up at the barrel. Start about a ½ an inch down, and as you put it in, just let it run. And you can see as the wire changes color. I've put 2 drops in there, and depending on the wicking ability of the wire that you're used, you might get as much as a ½ of a blade done. Just take something like a tissue and wipe it over it. Do this quite quickly because you don't want the paper stuck to it. You can continue down the blade 1 drop at a time and see how far it goes. But since we're at half the blade, let's turn it over. The reason why we're turning the blade over and letting it run towards the middle is because you don't want to get the crazy glue up here on the tang. That's a little bit dangerous because you'll never get the wire off and you'll have to rewire the blade again. So now we're doing the back side, and it's running down, and we'll add another little drop there and let it run, run. And if we want, again, to make sure that it's set, we'll take our paper towel and give it a quick buffing. And then we can look to see if indeed the entire wire is covered. Now what I'm going to do is to check to see if the glue is really holding by taking the blade out of the bending jig and flexing it backwards away from the wire, and indeed the wire is not popping out. Now that the wire is secured in the groove, it's ready to go and we can put the point in it. What I'd like to do now is put the blade back in the vise and insert first the pressure spring. In putting together the point, what you want to do is to take the spring first and insert it. Sometimes the spring may not actually go down into the cup, so you might just want to test it a little bit to put it in. Then what we do is we take the point itself, put it in. Now, you have to be careful about this because if you let it go when it's under tension, what's going to happen is you're going to be missing a tip and possibly the spring as they shoot out. Using a magnetized screwdriver is very, very helpful in playing with the little tip screws because they're so small and you have to be very careful about aligning the threads. I'm holding the point in here and you have to put a little tension on it. I also have my fingers underneath the screw hole, so in case I do drop the screw, it's going to fall into the gap between my fingers. The other thing I do is to back screw just a couple, so I make sure that the screw actually is in the threads. You don't want to cross thread the screws because that creates all sorts of problems and you may have to buy a new screw or possibly even rewire it if you strip the threads in the barrel. Now, a lot of people screw these screws absolutely tight. On this particular type of a point, I don't, because it makes it awfully difficult to get them out in case the screw head breaks. Now that we have the foil point in and the two screws are fixing it, let's put the whole foil together. What we're going to do is reverse the blade so that the tang is up. We're going to unwrap the wire that we so carefully wrapped on there before, making sure that we don't put kinks in it or break the wire. And then we're going to put an insulating sleeve on here, which just protects the wire. It's also required by the rules. We have to put one on. And just by turning it slightly, you get it started. And just push it on. And what we're going to do now is to put the guard on. Insert the wire through the hole and make sure it doesn't get pinched as you put the guard on. Now this particular guard is very, very tight on the tang, which is what it should be, and just slip it all the way down, being careful not to pinch the wire. A little bit of tension as you slip the guard on will make sure that it doesn't happen. Then put the wire through the hole of the socket and then insert it like the guard onto the foil. At this point, we've got both the guard and the socket on there, and you can adjust where you want to put the socket. For right-handed fencers, the socket will be on the left, and for left-handed fencers, the socket will be over here on the right. You notice that the wire is pointing away from me, and that will stay in place as I put the guard pad on. Now this pad really doesn't protect the fencer's fingers, it protects the wire from fencer's fingers. And once we have that in place, we know where the wire is, what we're going to do is insert the handle. And the handle has a groove in it that's right here. The purpose of that groove is to allow the wire some space. If you don't have the groove there, you're likely, as you tighten the handle, to break the wire. So we insert the handle, put it all the way down, and then put on a pommel. If you happen to have a pistol pommel, you'll probably want to put it on with one lock washer to keep it from tightening. And here we go.
There, it's nice and tight, snug, not overly tight, which will make a nice electrical connection. Now, we have this wire and it has insulation on it. With the German wires, they're coated with an epoxy as well as wrapped in cotton, and so we have to scrape off the cotton and the epoxy. And here's where the ubiquitous Swiss Army knife comes into play. You're just going to scrape it off and you can see that it's red. We've gotten past the cotton coat. And as we go down further, we have the epoxy coat, which comes off if you scrape it, but you have to be somewhat diligent in making sure it's clean. The other way people can take it off is by using sandpaper and just folding it over and polishing it. Some people try and burn it off. That's not recommended, as the epoxy fumes are somewhat toxic. Now that that's all done, what we're going to do is attach it. And on this particular model, which is a Leon Paul, just wrap it around the screw with holding the long end and tightening the screw. Now, if we want to make it nice and clean, and we don't have to go reach for our nippers or anything like that, you can just take the wire and wiggle it until it breaks. And there we have the assembly finished, with one exception. What we need to do is to tape the point. I like to tape the foils in two pieces. And the reason for this is because if you want to work on the screws, you don't have to throw away all of the tape that you so diligently had placed on there. So what we're going to do is to just put one piece here, starting on the side that covers where the wire is, and just smooth it on there, and then just wrap it around as we go. Up, a little bit of lint there, and making sure it is nice and tight on the blade. That way, it's not going to stick inside the barrel of a weight when somebody gets tested on the strip. At this point, it's not a bad idea to test the foil, as you don't want to have to uncover the tip screws which you just covered. So that's what we're going to do now. Now that we're going to test the foil, first thing we do is plug it into a test device. And most of the light test devices will go on and show one light when you've plugged the foil in. If you don't have a light, then there's some kind of a problem. Either the insulation hasn't been taken completely off of the wire, or possibly that the spring in the point hasn't made contact with the cup. Then what we're going to do is depress the point and the light should go out. When you release the point, that light should come back on. To test to see if the pressure spring is actually doing its job, take a 500-gram weight, place it on there, and depress it. The light should go out. When you release, the light should come back on. If that's fine, now it's time to put the last piece of tape on. And this one is not going to go the length of the blade, but it's going to go around the tip. And what we're going to do is put it just at the top of the barrel, so that there's no tape that's going to impede the travel of the tip itself. And there we have a foil that's ready for use for competition. There are essentially three kinds of epee wires. The oldest style here is this white one, which has a two-piece contact. There's a ring, and then there's a contact. This ring is important both when you take a point out of an old epee blade that needs to be rewired, and you have to have it, otherwise it will be almost impossible to adjust the travel. If you have two of them in there, you won't be able to put the point in it. This is the more modern edition of it. It's one piece, and it, like its predecessor, has two contacts in the front. Those two contacts in this third wire, which is a German wire, are recessed in a cup. And that cup actually will hold the travel spring from deviating. That's one of the advantages of this type of a wire. So what we're going to do is to use this third kind of wire and assemble an epee. This is a typical epee tip. It's composed of a barrel, the tip itself, 2 screws that hold the tip into the barrel, and a pressure spring. Well, in the process of putting together the epee, we're also going to be talking about what's called the contact spring, which is the spring on the end of the tip. When you buy new points or new tips, make sure that everything is of the same manufacturer, because normally you can buy the pieces separately or you can buy the complete tip. To wire an epee blade, there are 2 parts that we really have to be concerned with. One is the tip onto which we're going to affix the point, and the second is the tang. What we need to do when we take a look at the end where we're going to affix the point is to find out if there are any rough edges. See if it's sharp, because if it is, there's a chance it might strip the insulation off of the wire and create a short where we don't want one. What I do is just take a file and dress it, just ever so gently, making sure that all of the rough edges, all of the sharp edges are not sharp. And then the second thing is to make sure that if you do want the handle on an angle, that we bend the tang the proper way. Normally what we're going to do is to bend it down and to a particular direction. This epee is going to be for a left-hander, so what I'm going to do is to bend it ever so slightly to the right. So here we go. Take special tool, one that travels well. It's a steel pipe, and put it in there. That's going to pretty much hold it there, and we're going to bend the tang down a little bit, and then in the direction that we want. Also, what I'm going to do is straighten the whole tang a little bit since it's a little bent. And there we have it. This is bent for a left-hander. Okay, now that we've got this done, we can proceed to wiring the blade. The first thing we're going to do is to use the vise and lock the blade in place. Second thing we're going to do is to straighten out the epee wire. As you unroll the epee wire, you don't want to have kinks in it, because kinks are a potential weak spot in the wire. So unroll it carefully, making sure there are no kinks, and maybe running your fingers over it, just a smooth wire once or twice, and get the twists out of it. And then we will proceed to put the point on the blade. Taking the front end of the epee point, or the epee barrel, which is where the screw holes are, insert the 2 wires, just about an inch hanging out, and then put it into the groove. Then screw the barrel on, finger tight first, and then with a wrench, you tighten the barrel. Before you go any further, check to make sure that the wire slides freely. If indeed you've pinched the wire in there and it doesn't travel freely, then you're probably creating a weak spot. And if you've broken the wire, you've only lost about an inch. Gently pull the wire through until the contact is just at the front of the barrel. Just set it in there gently, and then use a point setter to push it in all the way to the bottom. Meantime, maintaining a little bit of tension just to keep the wires from being pinched inside the barrel. We're going now to line up the wires and put some tension on them before gluing. And this is necessary so that you don't create bumps in the wire which the errant hit might actually go off. What I do is separate the two wires and just with a little bit of tension run them all the way down to make sure there are no twists. Then when you get to the end, put them in the slot with not a great deal of tension, and then wrap the wire around the tang to hold it. At this point, if you're going to store the blade for a period of time, you can take a piece of tape and put it over here like this, or alternately, you can put a piece of tape over where you've wrapped it. Those will protect the wire if you're going to store it. Now, with the wire in place, what you probably will notice is that right here, just before the tang, the wire isn't sitting at the bottom of the groove. And what we're going to have to do is to glue that wire down before we proceed any further. We're going to tack this wire down to the bottom of the groove using a cyanoacrylate, what's commonly called as crazy glue. And we're going to use the glue plus a small instrument. I'm going to use here a tip screwdriver. One drop at the lowest point of the blade, and then we're going to push the wire down into it. Sometimes this gets a little tricky, but once you get it in there, just hold it until the glue sets, 10 or 15 seconds. Now that the glue is dried, what I'd like to do is to show you something that's interesting. While the blade has been held horizontally in the vise, you'll see that the glue has crept all the way down to this point where my finger is. And we're going to use this particular property in wiring the rest of this particular blade. First thing we're going to do is we're going to put a bend in it with the wire, and that bend will hold the wire down at the bottom of the groove. Not too big of a bend, just about this much. And the second thing we're going to do is to work with gravity, putting a small drop of the cyanoacrylate right about 1/2 inch from the top of the blade. And you can see it as it wicks its way down. And we can put this in 1 drop at a time. 2 drops generally will get to about the middle of the blade. You don't want to get it very close to the top of the blade because the wicking property may draw some of the cyanoacrylate into the point. But you can see how far down the 1 drop has gone. That's about 1/4 of the blade. So let's add another drop and watch it run down. If you want, you can also make this glue set even more quickly. The normal setting time on this glue is 10 to 15 seconds by using a paper towel, napkin, toilet paper, whatever, and just burnishing what you've just put in. This will make it set even more quickly. At this point, what we're going to do is reverse the blade, and I have to explain why we're doing this. You don't want to have the glue running down onto your tang and gluing your wires to the tang. So here we go with a little bit of glue here. Let it run towards the center. And if we want to, we can make sure that it sets very, very quickly. I'm just going to let it run until it meets the other. There it goes. Now we're just going to burnish it. And that should be it. The way you check is that you reverse bend the blade. And if you do, no wires should pop out. Okay, no wires are popping out, so that was a pretty good glue job. All right, now what we're going to do is actually put the epee together. Going back to the vise, put the blade into the vise, unwrap the wires, making sure that there are two of them. Haven't broken any, making sure there are no kinks in there. And then what we're going to do is to cover them each with a piece of insulation. This is required by the rules. It helps to prevent trickery, as the French call it, and it also helps the wires to survive. So what we're going to do is to put one of these pieces of what are called spaghetti on each of the wires. Sometimes twisting it a little bit will help. And here we are. Once you have the insulating sleeves on both of the wires, it's time to put the guard on. Now, an epee guard is eccentric. There's a section of it that's a little bit wider than the other side. And if you're going for right-handed, you want the maximum side covering the outside of the hand. For a left-hander, you've got that situation. So since this epee is going to be for a left-hander, we're going to take the two wires and place them through the guard, the hole in the guard. Holding them slightly taut, we're going to slip it over the tang until it bottoms. In putting on the guard socket, again, the two wires go through the hole, and then that goes over the tang. If you're dealing with a left-handed epee, as I am here, the guard socket will be to the right. If you're dealing with a right-handed, the guard socket will normally be to the left. It's a matter of personal preference for the fencer. So what we're going to do after that is put on a pad. Now this pad has more to do with protecting the wires than protecting the fencer's fingers from the guard. The wires basically have to be carefully aligned, as what we're going to do is to put the handle on. Now, some handles come without a groove, and we need to have that groove in there so that the wires are not pinched when we tighten up the handle. To do so, I'm just going to use a rat tail file and create my own groove. You really want to make sure that that groove is there. That's quite a nice groove. Now slip the handle on, making sure that the wires are in that groove. And then what we're going to do is to pop the pommel on. To strip the insulation off of the wires prior to connecting them, I use the very handy Swiss Army knife. And what you need to do is to scrape off all of the insulation. Sometimes it's just a matter of taking off a cotton layer, but in many instances the wires are coated with an epoxy. So you have to get below the epoxy in order to have a good electrical connection. Some people use sandpaper and just sit and polish off the insulation. What's not recommended is burning it off, because the temperature which is required to burn epoxy off of wire is also high enough to change the temper of the wire, and that may cause a weakening of it. Now that the wires are clean, let's attach them to the socket. You want to attach the wires to the two sockets that are the closest to each other, and you also want to attach them so that the wires come on the outside, closest to the guard of the socket. Now this, I'm not sure if you can see, but I'm just going to put the wire under it. One turn is all that's sufficient. That's all that's needed. And just tighten it down. Take the second wire and do the same thing. Now the insulation should come right up to the edge of the socket. That way there's no question about whether or not the wire is insulated. One turn, that's all you need around the sockets. I'm going to leave these little pigtails here in case I have to move things around as we adjust the epee. I'll take them off later. And now what we're going to do is to see if our wiring job was successful. We have the epee assembled, we have the wires connected to the socket, and now we're going to adjust the point and test to see if what we've done all works. So what we're going to use is a typical light box, and of course what we're going to do is plug it into the epee, and then without the pressure spring, what we're going to do is put the tip in. Then to press the tip, we should get one light. And when we let it go, that light should go out. Okay, that's fine. The circuit works. We shouldn't get two lights because two lights will indicate that we have a short between one of the wires and the blade. Okay, now we have to adjust the travel. Now, on the tip, there's a small spring, and that's a contact spring. That's what closes the circuit, similar to a doorbell switch. And it has to meet certain specifications. To do that, we need a set of gauges. These are commercially available, or you can use automotive spark plug gap gauges to check it. If you read in the rule books, you'll find out that this particular travel, that it's called, has to be below 0.5 millimeter. So what the gauge does, if we have a half, is we have to be able to put it in, depress the point, and not have the light go on. In this particular case, the travel is way too long, so we're going to have to adjust it. The way on these points that you do it is by twisting in the spring clockwise. Sometimes it's easy, sometimes it's difficult. But what you want to do is to get it so, indeed, if you have the shim in here, the gauge, and you depress the point, it doesn't go on. So we're going to have to continue to screw that spring in. And this process should be done a little bit at a time, because if you make the spring too short, you won't score any hits. Let's see if this works. The light does not go on, therefore it's adjusted. We remove the gauge, the light goes on. So we're now properly adjusted. I'm going to make a little test here by moving the point back and forth to see if indeed there's any intermittency. If it is intermittent, that means that the spring has been shortened too much. Okay, you notice that all of this adjustment was done without the pressure spring being in the point. Now we have to, in assembling the point, we have to put the pressure spring in. Then what we do is we put the point in, line up the holes, and using a magnetized screwdriver, put the screws in that hold the point together. This can be somewhat of a tedious process because you've got a spring inside trying to push the point out while you're trying to hold it steady. And what I do is I take a half turn or so backwards, counterclockwise, just to make sure that the screw is sitting properly in its screw hole before tightening it. Okay, do not over tighten those. With one screw in, what I like to do is to check to make sure that there's nothing that's a problem. No light? Good. We've got a light, it's still functioning. And then we'll do the other side. Again, using the magnetized screwdriver, we get the tip screw. And this time we don't have to hold on to the point very hard, just a little bit of pressure to depress it so that we can have access to the screw hole. And there we are. Snug tight, not overly tight. And indeed the point still works. One last test that we're going to make involves the weight. to make sure that indeed the point can reset 750 grams, which is the weight of this. Put it on, press it down, the light should go on. It does. When we release it, the light should go out, which it does. So we now have an epee that's almost ready to be used in competition. Do you remember the wires in the back? Those have to be taken off, and the easiest way is to just grab them, wiggle them around until they break off. And now we have an epee that's ready for competition. Body cords, that's an area that has often been neglected, but one which is very crucial to having good equipment. Since the USFA started checking body cords at national competitions, the number of problems on strip have basically fallen by about 80%. So a little bit of time, I think, needs to be spent with body cords. Now, there are two different kinds of body cords, obviously, one for epee and one for foil and saber. And I have some examples here on the table. And on the left, my left here, we have the two predominant styles of plugs that plug into foils. We have the bayonet and we have the two-prong version. Obviously, they serve the same function, and in order to understand that, what we're going to do is to begin with the epee. The epee body cord has two plugs that are identical. The pins are asymmetrically spaced, and they tell us a little bit about the function. In order to facilitate this, what we're going to do is to name them. We're going to give this one the name A, the middle one B, and the pin that is farthest away we're going to call C. So depending on which weapon you happen to be fencing, various of the pins happen to be involved. We're going to check them two ways. One, we're going to use a light box, and two, we're going to use a meter, which is the most precise way of doing it. What we're looking for in checking body cords is that indeed the body cord is conducting electricity in all three lines. And if indeed on this I short the center pin to either end, I should get a light. In this particular case, yes, I have one, and in that particular case, I get the other. In checking body cords, you should make sure that the pins are not loose or broken, because they can affect the conductivity between the reel and the body cord. Something else, if indeed body cord has a clear insulation on it, to check to see if there's a break is just to hold it up to the light and just stretch it, just pull it a little bit. And if indeed you have a clear area that appears you have a break in your line. Well, those are just some of the things about the epee, where you have the A, the B, and the C lines. The A and the B are the two pins that are closest to each other. You need to remember that as we go to the foil, because in foil we've got something that doesn't quite look the same on one end. And the A is connected to the alligator clip. And this alligator clip is what connects to the lame. It always connects to the lame. The B line, the center here on the bayonet, is the screw end. And the C is connected to the rest of the point. So we have A to the clip, B to the screw end, and C to the rest of the connector. The body cord that's probably more used in the world than any other is the two-prong. And in this, again, the A is connected to the alligator clip. The center pin, the B, is connected to the thin pin, the 3mm pin, and the C, the pin that's farthest away on the 3-pin plug, is connected to the 4mm, the fat pin, on the end of the body cord that connects into the foil. And this particular cord, like the others, you can see if there's a break, as it has clear insulation. There are other body cords that do not have clear insulation, and therefore it's harder to see the breaks. But what you can do is to test things electrically. What we're going to do here is to take a look at one of these body cords. We'll take the two-prong one first, and we'll plug it into our light box, and later we'll plug it into the meter to get a more precise reading. And what we've got here, we can get the lights to show, is take the A and connect it to the small pin, and we should get a light, which we do. As this is happening, just give the pins a little bit of a wiggle, give the wire a little bit of a tug and a little bit of a wiggle. If there's no problem, then the light will stay on and it will be steady. In order to test the other side, what we're going to do is to connect the B pin and also the C pin, and we should get two lights. And then we're going to wiggle everything around. Oh, we seem to have a little bit of a problem here with something being a little bit loose. So we're going to have to tighten up the connections. On this particular body cord, the screws are accessible and you don't have to take apart the housing. So let's see what we have here. Obviously, this particular body cord has a problem. As a good one, you wouldn't see the lights blinking. So what we're going to do right now is to fix it, because obviously whoever is fencing with this wants to have the best equipment possible. So the first thing that we're going to do is to open up the housing on this particular body cord. And fortunately, this particular model, we really don't have to do that much. We just take out one screw and that should open up what we need. Don't lose the screws and the nuts because they're hard to replace. There we are, we're now open. Now the real trick to working with body cords is to only work with one wire at a time. If you work with one wire at a time, then you know exactly where it can go. But if you take both wires out, you may have a problem trying to decide what's going where. So this particular one's not quite secure, and we're going to see what the problem may be. If there's a discoloration in the wire, which you may be able to see here, there's a good possibility that the wire is going bad there. So we're just going to cut the wire back behind it. We're going to discard that and strip off a new section of wire. We're going to insert that into the former hole and tighten the screw. Do the same for the other side. And tighten down this screw. Before we reassemble things, we're just going to check them to see if the situation is better. And yes, indeed, we don't get the blinking lights. So now we just put it back together and we'll be all set. And we will have a good body cord to use in competition. Now, In doing this, we've only been using the lights, but according to international specifications, what we should have is a resistance, an electrical resistance below 1 ohm. So I'm going to shift over to the meter, and this is going to give us some indication of exactly what the electrical resistance is from one end of a conductor to the other. Now, if you remember, the alligator clip is the A, and the pin on the end that's closest to the center pin is also the A. So we're going to attach the leads to the meter, and we have 1/10 of an ohm. That's certainly within the regulations. So we'll go to the B line, which is the middle, and we're going to go to the small pin, which is also the B on the other end. And there we've got 2/10 of an ohm. And then the C line, which is the fat pin on the foil plug, and we've got 2/10 of an ohm there. So this is certainly a body wire that can be taken to any international event. Okay, if we shift over to the bayonet type, again we're going to do a quick check with the meter, connect the alligator clip to the A line, and we have here, something that's a little bit higher. It's moving around. It's between 1 and 6 ohms. So we're probably going to have to do a little work. But let's see what we have on the B line and the C line. The B is the center pin and the very end of the connector. And what we have here, we have the same situation. And then at the C line, something that's not going to pass. Well, how do we deal with this? What we have to do is to take the covers off of the body cord ends. Just by this particular type, you peel it back, and you'll find that there are 3 screws. And over time, those screws can loosen, or there's a little corrosion that can build up in them. What we're just going to do is to take a small screwdriver, twist it around, and then snug them back up. If you do this once or twice a season, you'll discover that your body cords stay in relatively good shape. Now, those are 3 connections on the front. We also have 2 on the other end. And just pull the cover off, and you'll discover that there are 2 screws in there. Just do the same thing with that. Back them off a little bit, wiggle it around, and then snug them back up. Well, since I've done that, let's check. The A line, the alligator, to the A pin. 0.2 of an ohm. That's very good. Then we go to the B line, which is the very front, and we have 0.2. That's very good. And then the C line, we have 0.2, between 2 and 3. That's very good. As you're looking at this particular bayonet connector, don't neglect this screw or that screw. They may become loose. Just make sure that they're tight. Okay, and those are basically the problems that you're likely to have with body cords. This session has been primarily about foils and epees and the occasional body cord problem. We haven't talked about sabers, but sabers are relatively easy. You don't have to wire them. Basically, if it doesn't work, it's loose. Something's in there that's loose. Check all the connections, tighten up the pommel. If the blade is broken, just replace it and go back to fencing. Well, I hope this session has been an introduction to you that will help you to be a much better maintainer of your equipment. Well-maintained equipment gives confidence to a fencer,
And fencers, as they enter competitions, don't need extra worries. Hopefully, you'll have good equipment, it'll serve you well in competition, and if you have any problems, there are other people around who can certainly help you. Thank you for watching, and goodbye. I'm Ted Lee.